All right, we learned about the integration by parts formula, which was u dv, integral of that is equal to uv minus integral v du. And then we also remember lipit as a strategy to help us determine what u and v are. So start u from the bottom down, or select u from the bottom of top down, and then dv from the bottom up. Okay, and so we're going to try using that strategy and the formula to help us integrate each of these integrals. So x cosine 5x. Okay, so then I see there's a trig, so I'm going to select all of that for dv, and then x is going to be our u. And so what I like to do when I'm working this, because I have to use uv and v du, I like to just write out u and then du, and then v, and then dv. So dv I know is cosine 5x dx. It's that whole derivative. And then if I were to integrate that, I'd get 1/5 sine of 5x. Okay, u is x, and so then if I differentiate, I just get dx. Okay, so then integrating this is actually quite straightforward. So then it's uv, so x, and then times 1/5 sine 5x. And again, if you want to write that differently, like you sure can. I'm not going to right now. Integral, and then it's v du. So v is 1/5 sine 5x, and then du would be dx. That works out nicely. And I can actually go further and complete this. I can do the integral of the second piece of this formula. So I'd get x over 5 sine 5x, and then sine would integrate to cosine. Okay, so cosine 5x, I'd have to divide by another 5, which would make it 1 over 25. And then integrating sine to cosine, I end up with a negative, so I actually end up with a plus here. And then finally, since I finished that integral, I'd have plus c. Notice in the original formula here, right, there's no plus c's needed because it's just a rearrangement of the product rule. Okay, but if you do an integral, if you do the integration, then you need the plus c. All right. Next one. All right, so we have lipid up in the corner, so I need to select u, du, v, dv. Okay. Take 10 seconds, see if you can figure out what u, v, du, dv are. Okay. So if I'm picking u from the bottom, I don't have logs or inverse trig, but I do have a polynomial, which is just x, and then that would be dx. That means then that e to the minus x dx would be dv, and negative e to the negative x would be v. Okay? So then here, I get that that's equal to u times dv plus v, minus integral, v, so minus e to the minus x du, which would just be dx. Okay, so that makes it a plus, and then I get minus x e to the negative x, so that'd be plus, and then if I do the integral, I get another negative, so it's a triple negative of, oops, that's not x, that would be e to the minus x, and then all plus c. All right. Next one, natural log of x. Okay, so then this one, believe it or not, you can use integration by parts for this one. U du, and then v dv. Again, take a moment to complete each one of these. So picking u, right, if I remember lipit, logs are first, so that would mean natural log of x is my u, so then 1 over x dx would be du. And then, let's see, this would just be dx. That's a polynomial, right? We actually end up no trigs, no exponentials, but we'd have a polynomial, which is dx, making v just x. So then that means that this whole thing would be uv, so you could write it as x, natural log of x, and then minus integral v du times 1 over x dx. Those would just reduce to 1. And so then when we integrate, this ends up being kind of nice. X ln x minus x plus c. Okay, again, the plus c comes from the integrating that second expression. Okay, and the last one in the video here, I want you to pause the video, try it on your own, and resume when you're ready to see the solution. And here's the answer. All right, so arctangent of 4t was our inverse trig function, so that's our u, right? And then thinking through what our dv would be, there's no trig, there's no normal trig, there's no exponential, so then all we're left with is the polynomial that is dt. And so then following that through with the integration by parts formula, we would get, 4t over 1 plus 16t inside the integral in the second term, which to integrate that, we have to do a u substitution, which is kind of fun. And so then we get 1 plus 16t squared as our u, differentiate that, and then in order to get that 4t dt to pop out, we would need to divide both sides by 8. So 1/8 du would be equal to that 4t dt, and then when you integrate it, you end up with negative 1/8 natural log absolute value of, and technically you can use parentheses here, 1 plus 16t squared plus c. And actually I'm going to, because that is always going to be positive anyway, so I don't need the absolute values. If you had the absolute values, you're fine though. All right, so there we go. We completed the last example, still using integration by parts, but seeing though that we can throw u substitution into the mix as well.